put it on YouTube or Google Classroom or whatever. The first section is all about knowing where each thing is. That section is pretty easy. I'll go back and fill in those answers. But number 7 is where it gets a little tricky, because you have to know that in order to, it says which two equations have the same range. In order to find the range, it's very helpful to first know the vertex for each of these. Because your vertex, remember, once you know the vertex, that can help you to know which number should be a part of your range. And then also, if you know whether it opens up or down, that can help you to know which inequality goes with the range. So first I'm going to put this one in my calculator so I can find the vertex. If I press second graph, remember your vertex should be in between the symmetrical pairs. So if I see 3, 3, 0, 0, that means my vertex is at 0, 4. And if I press graph, I can see that it opens down. Those are the two things you need to know, so then you can match the which two equations have the same range. So now I'm going to put this one in there, negative 4x squared, and then I'm going to look for my range. I'm sorry, my vertex. Remember, if you see symmetrical pair, the vertex is right in the middle. So this one's 0, 0. And if I press graph, I can look and see that the parabola opens down. Because in order for it to have the same range, it should be opening the same way. And the vertex, which piece of the vertex needs to be the same? The y value of the vertex needs to be the same, and it should point the same way. So we know that this cannot be an answer because it does not have the same y value of the vertex. Now let's try putting this one in there. Negative 3x squared plus 4, Negative 3x squared plus 4. Press second graph and start looking for that vertex. You're going to see some matches. If you don't see many matches, then you need to either move it up or move it down. However, this vertex is 0, 4. And one way without pressing graph to know if it opens up or down is to look at the coefficient. If the coefficient is negative, that means it's going to open down. Therefore, these two would have the same range because they have the same y value of the vertex and they both point down. Now we got to figure out which of the other one. Well, one thing you should know is that this coefficient is an invisible 1, which means it's positive. If you put this in your calculator, you're going to see that it opens up. And if it opens up, it cannot have the same range as the one that opens down. So it can't be that one either. So let's check this one. Negative 7x squared plus 4. If you look for the vertex of that one, it's right there in between symmetric pair. So yes, that one has 0, 4 for a vertex. And if you really want to double check it, it does point down because of the negative coefficient. So it does say which two equations have the same range. Excuse me? Why did I cross this one out? Because it opens up. Yes. All right. Please take note to that one. Number 8 says, what are the domain and range of this one? Well, it's not a soccer ball, rocket ship. It's not any type of specific problem that deals with anything getting thrown. So domain is all real numbers. However, the range, in order to find the range, we have to know we need to know these two things here. We need to know the vertex of it, and we need to know whether it opens up or opens down. So I'm going to pause that real quick so you guys can try. What? Does it open up or down? The vertex, thank you, is 5, 1.
It opens up.
And it opens up. So since it opens up, we need to use a greater than or equal to. Because that means the parabola is only things that are above that minimum value of a 1. Remember, the y value of the vertex helps you to know which value to use for our range. You're going to do that same thing for number 9. Not right now, though. Towards the end of class. Yes, we have a test tomorrow. Okay? Now what I'm going to do is I'm going to flip over. I'm going to skip around a little bit. Right now I'm going to flip over to the back so we can talk about the word problem. So then those people that need to take their assessment can do that. This problem right here. The graph below represents the height of a diver versus the time after the diver jumps from a springboard. What is a reasonable domain, bless you, for the graph? Now the domain would be all real numbers if we were not talking about anything specific. Like this one, domain, all real numbers. This one, domain, all real numbers. However, this one, the domain is simply when did the time start and when did it stop. So it's from 0 to 3.5. And since we are dealing with x values, because domain is the x, and we know that the x's are everything that's greater than 0, but less than or equal to 3.5. The diver is still ascending at 1.5 seconds. Please turn them off. True or false? The diver is still ascending. That means going up or increasing. So let's look at 1.5 and see. At this point, is the diver still increasing at that point? No, that's false. If they have a question about 1.5 seconds specifically, go to the 1.5 on the graph and see what it looks like. Same thing here, true or false. The diver starts their descent. That means you're decreasing at approximately 1 second. So at 1 second, if you're right here, that's the vertex, which is where the direction changes. First the diver was up and then he dives down, or she. So that's true. What does the point 3.5, 0 mean in this situation? Well, we know that 3.5, 0 is called a what? In our vocabulary, yes, it is called a root because it has a 0 right here. However, according to this situation, that's where the diving ends. That's where he hits the water, or that's when they stop taking the time or something like that. So when the dive was over, because they stopped taking the time once you hit the water, I guess. Normally it's like when the ball hit the ground. That's what we've been saying all week. But in this case, we don't want to say when the diver hit the ground. I'm going to pause the video. Alright, now we're moving to 16 because this is something that we haven't talked about in a while. Tomorrow's a test. Tomorrow's a test. Alright. So, 16. This is a calculator problem. It says given f of x equals, this is the equation, what is the value of f of 5? So they want you to put the equation in the y1. Please do that. Especially since you're in class right now, you're not at home. If you're at home watching the video, then it's just a reminder, hopefully. Once you put that in your table, once you put that in the y1, you go to your table, and this is asking you about something. A lot of people don't remember what this means. Well, if that number is on the inside of the parentheses, that means that number is an x value. What do you think? The number is an x or a y? If it's on the inside of the parentheses, it is a x value. So that number is an x. You need to figure out the y that goes with it. So your answer is going to be whatever y that's with that one. Sure that you have put the number in there. Did you put that negative in front?
Probably not.
And then you put x squared plus 4. Because it's like negative something. So maybe you should try it again. Try it again. Make sure your equation's right. This 5 has nothing to do with this problem 17. Yes, you need to be careful because notice 17 has an x of 17. Remember the inside, that means that x is 17. Find the y that's with it for this equation. Number 18 is a little bit tricky, so please pay attention here. It says if Jerry translated the parent quadratic function, I'm sorry, no. After you do 16 and 17, I want to show you how 14 is different. Because notice on number 14 it says, what is the value or values of x when g of x equals negative 8? So do you see how this one's different? Because, now, this is the one you asked about. Now they don't give you the number inside the parentheses. Now they're telling you that the y is negative 8. So you're going to have two answers. You're going to look there for x equals what? Negative 3. And then you're also going to look there for x equals negative 1.
We can't see it.
Oh, sorry. There's two answers for this one. On number 14, notice this negative 8 is not in the parentheses. That means they're now telling you to look for where the y is negative 8. Mm-hmm. The axis of symmetry is not at points, it's a line. Okay? This right here should be pretty easy to finish up. What are the zeros? What's another name for zeros? Roots, x-intercepts. However, what about when you're looking at a table? Your roots or your zeros is where you see a zero back here.
So like
Exactly. You're looking right in your table. Which point is symmetric to 2, 7? People don't know what symmetric means. The same what? The same y value. I'm sorry, I didn't hear you. Yes, and then you have to actually go look in your table because remember, this is where you see symmetric pair, another symmetric pair. However, this one, it's missing a number. So that's when you and then you go backwards and you have to figure out where that extra piece of the table is missing. In order to know the axis of symmetry, you have to know the vertex. And the vertex is right there in the middle. Now over here the vertex is helping us find the range. However, now it can definitely help you find the axis of symmetry. So the axis of symmetry, y equals negative 2. And nobody's telling me why I'm wrong. That's sad. We've talked about the axis of symmetry. It better be x equals. Better be an x equals for axis of symmetry. Or you're going to get it wrong. There is one more part, but I need to go get copies for it, so just give me a second. Hold on. We are still in the middle of getting this review done. I think there's really only maybe one or maybe two things we need to talk about. Now I'm flipping it to 26. If you look at 26, thank you. We normally only compare things to when it's in the quadratic parent function first. However, notice, Brian, come on, dear. However, notice this is already shifted. They've already moved it a little bit for you. And right now, can anybody tell me how it's shifted?
To the right.
Ah, you're telling me it's to the right?
No.
Only right or left or in the parentheses. So, actually, this means it's already down 6. And hold on. And then they tell you you need to shift it up 7 more. So from this down 6, you need to add 7 to that. Or if you're looking in the calculator, it's down here at 6. And you need to move it up 7 places. So what would it be? And you don't need to change the 4 at all, because the 4 doesn't really have anything to do with if it's shifting up, down, left, or right. But if you're at -6 and you add 7 to that, what would be the new value back here? +1, because it was down here at 6 and you just move it up. It's kind of like moving it up the ladder 7 spaces. So now you have a +1. That's very similar to number 25, because on 25 it's already moved. Number 27, this one is currently at the origin, at the 0, 0. If you are sleeping, you will not be able to have a restroom pass. So please pay attention to the review. All right. So notice first it was at a 1. Now it's at a 1/5. What happened to the coefficient? It's now, first it was 1. Now it's that. The coefficient is now what? Is it bigger or smaller? It was at a 1, now it's there. If the coefficient is smaller or gets smaller, what does that mean? That means it's wider, which is a vertical compress. Ah, be careful. Yes, wider is compress. However, on this one, first it was at a 1, now it is bigger. And when the coefficient is or gets bigger, that means it is a stretch, vertical stretch, which is the same thing. And I should have wrote either narrow or skinny for that one. And you can put it in the calculator and see it. If first I put an x squared, now I put 1/5, and I'm going back to that top one. First, that one is the quadratic parent, and now look, you can see how it's wider. That's a vertical compress. So you can definitely use the calculator to help you if you need to. Okay.
Hold up, I got it. This word, how do you do number 18? Wait.
Oh, okay, I'll show you that one.
Oh, the formula is in there.
Number 29, this is a stat edit problem. Yeah, I didn't explain it to everybody. She can get it though. This is a stat edit problem. Remember, you're going to use stat edit. L1, L2, fill in the blanks. However, when you go stat over to calc, does anybody remember which number you're going to press this time?
5.
Not number 4, because it's not linear. Number 5. Okay. Number 5. And then it's going to give you an A, a B, and a C. So then you can write your equation. Let me show you how it looks. 0, 4, 12, 50, 46, 14. You see how you go down to number 5 this time because it's a quadratic, even though it says quad reg, that's something else. So when you get your A, B, and C, so then you'll end up with y equals, and it gives you how the equation's supposed to look. What is the A? Negative 0.25 x squared. The B is 0. So that means there is no x term because it's 0 x's. You just put 0. Like, you could put 0x, but on the test, they're not going to put it. It's just plus 50. Only because one of them is 0. Or, remember sometimes they change decimal to fraction. Remember math enter can help you. That would be negative 1 over 4 x squared plus 50. This one down here is all about using your calculator to look at it. I'm going to go ahead and pause it so you guys can try it. Alright, so for 30, 31, 32, it says the graph opens up. Which graph opens up? That means it looks like this. You got H, thank you. Yes, because the coefficient is positive, it's definitely going to open up. The graph is wider. Wider means vertical compressed. And you're saying that's G. Yes, because it is a smaller coefficient. And then the graph has 1, 0. Do you remember what 1, 0 means? No. And they've done this using their calculator. 1, 0 means touches the X once. Touches the X axis one time. And there is this one right here, which is F. If it touches the X one time, the vertex is going to be right there on the X axis somewhere. Alright, because, yep, that's it for that one. Number 25. We didn't do that one yet. So remember, normally we look at everything and we base it off of the parent function that's like this. So it's at 0, 0. Then if we need to shift it, then we move it. But this one is not already at 0, 0. They're telling you they already shifted it. Where at?
Down.
So look, no, it's already at negative 1 down here. It's down here. And then it says we need to shift it down 9 units. So from here, you move it down 9 more. So it's already at the negative 1. You need to just subtract 9 from that. Subtract 9 from negative 1. That's it. So what should it be? X squared minus 10, or y equals x squared minus 10. Not at the moment. Everything else is pretty good. Sorry, number 18, if you haven't done that one yet, that's the last one I'm talking about on here. Number 18 says, if Jerry translated the parent quadratic function y equals x squared so that the vertex is negative 2, 10. So yes, on this one, the vertex is the parent. It's right at the origin. Right now it's at the origin. And they're saying they moved it to negative 2, 10. So now where is it at? It's negative 2 up 10. How did they move it? How did it get shifted? Because your shifts can help you write the equation. So they shifted it which way? They shifted it up, yes, and also to the left. And remember, any right or left shifts happen in the parentheses. So how many to the left?
10.
How many to the left? 10 to the left? No. It was only 2 to the left. So that should be x plus 2 in there because it was just 2 to the left. And then, that's alright, then it got shifted up 10. Up 10, yeah, so that's the up shift. That's the left shift.